Okay, so we are here with a question that came in the IIT JEE 2025, and this question based on the moment of inertia. The question is from a sphere of mass capital M and radius capital R, a cavity of radius r by 2 is created. Find the moment of inertia about an axis passing through the center of a sphere and the cavity. Now here, the important word is the sphere. So we know the moment of inertia of a solid sphere, that is 2 by 5 mr square, about an axis that passes through the center of the sphere. And there can be an infinite number of axes that passes through the center of a sphere, and the mi is going to be same about all the infinite possible axes. Okay, now here we have one more point which is very important in the question, and that is an axis passing through the center of sphere and cavity. It means we are supposed to find out the mi of the system about an axis that passes to the centers of both the sphere, that is the sphere of radius capital R and the sphere of radius capital R by 2. Okay, now let's move to the cavity portion. Now, what can impact the cavity had on the system? The cavity had destroyed the symmetry of the sphere. Okay, now because of this, finding the mi will be difficult. Okay, so how to re-establish the symmetry. Okay, how to re-establish it? Now, if I fill the cavity with a mass m, or whatever mass is required to fill the cavity, then a symmetry can be re-established here. Okay, so what we're going to do is we are going to fill the cavity with a mass. Suppose the required mass is small m. Okay, small m. Since we are adding a mass small m from outside, so we have to subtract also. Same amount of mass need to be subtracted, that is minus m should also be superimposed. Okay, now this is a problem based on superimposition, you know, or you may have learned about the principle of superposition. Okay, so we're going to use that superposition of masses here. Now it means I can see the whole setup as a combination of two kinds of mass. One is capital M, that belongs to, or that is because of the solid sphere of radius capital R, and the other mass is of that of the cavity, and its mass is minus m. It means I am assuming the cavity to be a sphere of mass minus m, because I have added a small mass m to complete the symmetry of the sphere of radius capital R. So I am adding minus m because I have added extra mass from outside. Okay, that's why. Now, so next question would be how to calculate the value of minus m in terms of the mass of the solid sphere. Okay, so since the density is same for both, I'm going to take the ratio here. Okay, I'm going to take the ratio, the volume of sphere of radius capital R. So let's say it capital V1, and the volume of sphere of radius capital R by 2 as V2. Take the ratio, it is 8 by 1, and since the density is same, so if you multiply rho in the numerator and the denominator, you will get the mass. So the small m can be found in terms of the capital M, and it is capital M by 8. Okay, if you want, you can multiply by rho, but it will get cancelled, so it has no impact. Okay, so once you multiply it, what you're left with? You're left with the mass, and this can be called as capital M. This whole portion can be called as capital M, and this whole portion is small m. Okay, so small m will be 8 by, so the small m will be capital M by 8. Okay, once you have found out the masses of the two spheres, and one is capital M mass and the other is capital M by 8, but here it is minus, and the second one has the minus 7. This is capital M by 8. Okay, now finding out the mi about an axis that passes through the centers of the two spheres, that is PQ. 2 by 5 mr square plus 2 by 5 minus m into r by 2 whole square. 2 by 5 mr square minus 2 by 5 into m by 8. Now just replace or substitute the value of m in place of minus m here, so in terms of capital M. So this is what we're gonna end up with. Now take to verify mr square common. Now we are left with 1 minus 1 by 32. So after small calculation, we are having 31 by 80 into mr square as the final answer, and I think this matches with the option number 2. Okay, so here, so I hope you guys like will like the video, and if you find the content useful, kindly subscribe and click the thumbs up button. Okay, see you next time. Bye bye.